Soda Can Calorimeter Lab by Arlene Ayala, Jessica Rodriguez, and Melanie Cruz.
This is our calories lab. The purpose of this lab was to observe and determine the calorie content of chips and how the temperature of the water can change when exposed to the fire on the chip.
The law of conservation states that energy cannot be created or destroyed, but it only can change in form. The first law of thermodynamics states that energy lost by one body is gained by another body.
Specific heat is the heat that is required to raise the temperature of 1 gram of a substance by 1 degree Celsius. The equation to find heat is Q equals mass times specific heat times temperature.
Our first material for this lab was that we needed 3 food samples, which were a Cheeto Puff, a Funyun, and a Cheez-It. Also, empty soda can to hold our water, a candle to set fire to the food sources, a thermometer to measure the change in temperature, a lighter to light the candle, a long wooden splint to hold the soda can over the fire on the stand, a pin to hold the chips on, a cork to hold the pin with the food on it to hold under the can, a stand with a metal ring to hold over the food, 5 milliliters of water to indicate the change in temperature, a scale to weigh all the chips before and after they were burned, a burette to give exactly 50 milliliters of water.
To perform this lab, we first pushed the pin in the cork to create a food holder. Then we placed the food sample on the pin and weighed it on the scale. Third, we added 50 milliliters of water into an empty canned soda, and we placed it on the wooden rod through the tab. Next, we suspended the rod on the stand in the metal ring. Next, we put the thermometer in the can and not letting it touch the bottom of it.
Then we placed the pin with the sample under the can by 2.5 centimeters and lit it on fire. Next, we lit the food sample with the candle. Once the fire went out, we checked the temperature of the water with the thermometer that was sitting in the can. Then we weighed the mass of the burnt food sample on the pin. Then we repeat the steps needed for each food sample. The initial mass of the Cheeto Puff was 5 grams. The final mass was 4.1 grams, which means 1.4 grams of the Cheeto Puff burned. The temperature change in water was 11 degrees Celsius.
The initial mass of the Funyun was 5.3 grams. The final mass was 3.5 grams, which means 0.8 grams of the Funyun burned. The temperature change is 9 degrees Celsius.
The initial mass of the Cheez-It is 3.9 grams. The final mass is 3.1 grams, which means that 0.4 grams is burned. The temperature change in the water is 5 degrees Celsius.
During this lab, we lit a chip on fire and used it to change the temperature of the water in the soda can. We found the mass of the chip before and after it was burned and the temperature of the water before and after lighting it with the chip. We needed to calculate the heat gained by the water. We calculated the heat with the equation Q equals mass times change in temperature times specific heat. We used the data we collected in the lab to plug into this equation.
We divided the heat gained in the water by the mass of the food burned, and we found that the Cheeto Puff's experimental energy content was 0.392 calories per gram. The Funyun's experimental energy content was 0.5625 calories per gram. The Cheez-It's experimental energy content was 0.625 calories per gram.
Some sources of error that could have happened were the wind, because this could affect the flame and could go out faster. Also the surrounding atmosphere. Also the ashes falling from the food sample could change it because the mass wouldn't be accurate.